All right, welcome to one of our last videos. We are going to look at triangle similarity. So we want to, this is on page 23 in your packet. If you'll go ahead and open to that page and follow along with me, that would be wonderful. We are looking at triangle congruence. I'm sorry, we have been looking at triangle congruence, but we are now transitioning to triangle similarity. So they're not the same size, same shape, but they're similar. So what does that mean? Let's look at that. Previously we learned about dilations, which create similar figures. We showed that each corresponding side length had to be not congruent anymore, but now proportional. And each corresponding angle measure had to be congruent. So the angles stay congruent, but the sides need to be proportional. Way back in Unit 1, we learned how to prove two triangles were congruent by using 5 theorems. Remember, we watched that little video, side, 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 angle, 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 side, and that last one, hypotenuse, leg, which is the one exception to the angle, side, side, or side, side, angle rule. All right, using these theorems, it was not necessary to prove every single angle and side. Simply prove these pieces, and in most cases it was 3 pieces, was enough information to conclusively prove that the triangles were congruent. In this lesson, we'll be learning 3 similar postulates to prove 2 or more triangles are similar. So we have the angle-angle postulate, angle-angle similarity theorem. If 2 blanks of one triangle are congruent to 2 blanks of another triangle, so what are these blanks? 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. All right, so here we have 55, 35, that's 90, so this must be the complement. So that must be 55. 5, 6, 7, 8, 9, right? Adds up to 90 degrees. And this must be 35. Well, actually that's all we need. So 55, 55 are congruent and 90, 90 are congruent. So if K is congruent to M and J is congruent to P, then sorry, we're talking about angles here. Then they are similar. Are these triangles similar? Yes, they are. All right. If the 3 sides of one triangle are proportional, very important word, if the 3 sides are proportional to the 3 sides of another triangle, then the triangles are similar. Right? It just means that one was dilated, larger, or smaller. Okay. So how are we going to check that? So we want to check ratios. And I'm going to get out a little calculator because some of these are going to be fun. Okay, let's see. Here's a calculator. Okay, so we are going to check that they are similar. We want to make sure that it's the corresponding sides that we're checking. Here, it doesn't give me a statement. It's not saying, is triangle RSQ similar to TVU? Oftentimes we'll say the order so you know what side corresponds to what side. I think here it's pretty clear the smallest side is going to correspond with the smallest side. So I need to pick one or the other and put it on top. 2.4 divided by 4. And we want to see, is that equal to 4.2 over 7? And is that equal to 4.2 over 7? Well, I could tell you right now, you could tell me right now that these two are obviously equal because they're the same ratio, but are these equal to those? All right, so let's check that out. 4.2 divided by 7, we get 0.6, 6/10. All right, we're going to see, is that equal to 2.4 divided by 4? 0.6. All right, so we have shown that the sides are proportional. This is, to put small over large, so this is 6/10 the size of that. right? If we multiply by this scale factor, 6/10, we will get from here to there. All right, so yes, they are similar. All right, and the last one, the side angle side. If two blanks of one triangle are proportional, so what needs to be proportional? Yep, the sides. If the two sides are proportional to two sides of another triangle and their angles. Ooh, not just angles. There's two words here. What kind of angle is that? That's a very special angle. It's their, yes, their included angle. Ooh, sorry. That is not very clear. Let's try that again. Included angle, right? And included doesn't just mean that it's a part of it. It means that it's in the middle. All right. If the included angles are congruent, then the triangles are similar. All right, so we've got side, angle, and side, side are the three ways that we have to prove triangle similarity. Okay, over here I see that one angle that's included is congruent. 25 degrees is the same as 25 degrees. Here I have 3/2, which is 1.5. And I want to see, is that equal to 5.4 over 3.6? All right. If we think about factors of 9, this is 9 times 4 and 9 times 6. So I could just make this 6/4, and I see that that is 1.5. But you could just type in 5.4 divided by 3.6, and we see it is 1.5. All right, so we want to check that, make sure that the sides are proportional. Okay, great. So are these similar? Yes, they are. Excuse me. All right, so you guys have some practice. You want to check with those three: angle, angle, side, 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 angle, side. And we just went through 3 of them. All right, great. Sometimes there isn't enough information. So if you're not given enough information, it's okay to state that. Like, I cannot clearly see that they are proportional, or if they don't all equal, if the ratios of the sides don't equal the same value, then they're not proportional, or they're not similar. Okay, so go ahead and practice that page. All right, this is more practice. Here it's saying, oh, similar. I don't know if we've gone over that symbol right here. So we've done this symbol, congruent, right? Congruent. But this similar right here was just the symbol right above the equal sign. That's our similar symbol. Similar. Okay. So here I'm asking, just if I give you this triangle VUT, VUT, I want you to tell me what triangle is it similar to. So it's really important to figure out, is this side, does this side correspond to this side or that side? So you might have to do a little testing to make sure that the sides end up being proportional, but you need to set up that, make sure that this is to this as that is to that, or this is to this as that is to that. You need to figure out which one of those is going to be equal to figure out which sides correspond. Okay? All right, so that is more practice. And more practice. Lovely. All right, use proportions with triangle similarity. Here it's just some practice, a little bit of algebra. We can do a couple together. We're going to get some, this is some challenge. We're going to get some quadratic answers over here. Let me put that away. I don't think we need that right now. I think I'll just do 1 or 2 of these. Here we can set up cross multiplication because we have an equal side, one fraction equals another fraction. We can cross multiply. 12 times x is equal to 18 times 22. Multiply that out, divide by 12, and you've got your answer. Okay. Here you're going to need to distribute a bit. So I have 2 times 2y plus 1 is equal to 5 times 3 y minus 2. Then we're going to distribute that 2 in and distribute that 5 in, and then get all our y's together, get all our numbers together. We're going to let's say subtract 4, 11y. Here I'm going to add 10, 12, so divide by 11. So y equals 12 elevenths. I know that looks weird, but that's our answer. Okay? All right. Cool. So try some of those. Let's try one of the challenges together and refresh your memory on quadratics a little. Here, we're going to multiply 8 times 2 is 16. A plus 1 times a plus 1. I'll write it out. A plus 1 times a plus 1. I'm going to distribute a to both of these places. So I get a squared. A times 1 is just a. 1 times a is a. And 1 times 1 is 1. So we get a squared plus 2a plus 1 equals 16. Subtract 16 from both sides. And we get negative 15. All right, so now we need to factor this. Give me 1 second. All right, we want to say what times what is 15 that adds to 2. 1 times what is 15? Well, 15, 5 and 3. 5 and 3 multiply to get 15 and add to get 2, but I need the 15 to be negative and the 2 to be positive. So we're going to make a positive 5 and a negative 3, and that will work out. A squared plus 5 minus 3 and minus 15. We're good to go. So our solutions are going to be what makes that equal 0, negative 5, and what makes that equal 0, 3. So those are our two solutions to this problem. We want to double check, make sure we don't make the denominator 0. All right. All right, here are some more practice problems. And again, more practice problems. It's just determine if they're similar by angle, angle, side, 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 or side, angle, side. All right. That is a lot of practice. Okay. All right. We are going to look at doing some proofs. So similarity proofs are so much simpler. They usually have 1 or 2 steps. They're pretty self-explanatory. Here it's kind of, it'll show you how to start them. So it gives you partial pieces. So here this piece is given, so we're going to write given. What else is given? I and L. Angle I is congruent to angle L. And if we know 2 angles are congruent, then we can prove that those 2 triangles are similar by angle, angle. And that's it. So these are pretty straightforward. So we're just checking for angle, angle, side, and side, side, side. So here, it tells me by side, side, side. Well, all 3 sides are proportional, right? So that given statement is given, and I can show that what triangle is similar to what triangle. So it's important the order that we put them. So here, ST. Oh, notice I put the tick mark. That is not a good idea. But ST, this side, is proportional to WV. I don't want to put the tick mark because the tick mark says that they're the same length, and we're not saying they're the same length, we're just saying that these sides correspond. So TU corresponds with VX, and SU, I'm just putting some symbols so I can keep track of what side is what. So when I write out the triangle STU, I'm going to follow that same path, star, square, circle. So star, square, circle, WVX. Oh, not congruent. Similar to triangle WVX. It's important we put the order in the correct order. Okay, so those are some more practice. Here, you're writing the whole proof out, state your givens, identify how you can state that those 2 are similar. All right. I think I'm going to end this video now because I have students here that need some help. So I will do another video to continue the rest later. Okay, thanks for watching.